All right, folks. Next up, we have Sean Gallagher speaking on AI in InfoSec and birding, which I am really excited about. Sean is a principal threat researcher for Sophos, where he is part of the cross-functional research data analysis and technical comms team known as XOps. Previously, Sean was the information security and national security editor at Ars Technica. Among other jobs in technology journalism, he's also a former Navy officer and is known otherwise mainly for his shoulder cat and bird social media content, which I confess is actually how I know Sean. Take it away, Sean. I'm real excited about this.
Thanks, El. Hello, everybody. Today, I'm here to talk to you about birds first and AI in InfoSec second. And there's actually a connection via AI. And so about halfway through, I will give you a chance to ask some questions about the birding piece, and then we'll move on to the InfoSec piece. So birding, or burbing, depending upon who you are. Why? Why did I get into this? Well, like all other hobbies, this is a huge mental health boost. Started for me, I'd done on and off casual bird watching throughout my life, but beginning of COVID, my wife encouraged us to get outside to do something, and this was the best thing to do when we didn't want to mingle with other people. You can start with birding by just looking out the window. And I look out my window. I have a few here. I can see, well, usually pigeons and sparrows because I live in Baltimore City, so there's not a whole lot of variety. But birds are everywhere, and they're on every continent of the planet and in all of the oceans, and they're mostly real. So despite what you hear from the propaganda departments of birds aren't real. The best part about birding is that once you start getting into it, even if you're a more indoorsy person, it gets you outside, gets you out, it gets you some vitamin D, gets you out in the fresh air or whatever kind of air you're living in. And you bump into people who are part of a community that are much like InfoSec, and that they're happy to share knowledge about what you're doing, you know, birds of a feather and all that. And they're willing to direct you to places and give you tips on where to go and what to use to see more birds and enjoy it more. Birding also improves your visual and analytic skills. Honestly, if once you start watching birds, you will never not see a bird move somewhere in your frame of vision. If there's a bird nearby and you see it, your head will turn to it. But it also helps with distinguishing of color, analyzing objects by their shape and things like that. This has all been proven by scientists who studied cognitive impacts of birding. It's also citizen science. So a lot of information, as we'll see as I go through this talk, gets collected by birders and shared in a database that is used by researchers. Organizations such as Audubon, the Macaulay Library at Cornell, and the Cornell Lab of Ornithology, and a number of other organizations collect information from birders and use it to drive research on the population of birds, their range, changes over time, and this often reflects environmental changes and things that we're all concerned about, and it drives conservation efforts. And lastly, birds are just a huge dose of serotonin. Once you start going to it, it's the same as any other activity where you get gratification out of looking at birds or whatever you're doing. But for my case, birds around all the time. I look at birds, I feel calmer, I feel happier. I don't have to worry. I don't think so much about my day job, which is finding bad things on the internet. Birding is also real life Pokemon. I mean, birds are Pokemon. They're descended from theropods, the dinosaurs. And much like in the game of Pokemon, once you start doing this, you got to see them all. And you keep a list of the birds you see, a life list, often using a birding app, which is your Pokedex. You don't need a Pokemon ball. You don't need a Pokeball. You just need a camera or binoculars, a pad to write it down, or a smartphone to enter your what you've seen, your observations, and your life list is your score. So you're constantly keeping score. You can compete against other people around you. You can see what birds they've seen, and you may have seen the really horrible movie Big Day with Jack Black. No offense to Jack Black, which was about birders doing a very big year, trying to see the most possible birds in one year. There are people who do that, but you don't need to be that deeply invested in it to be competitive. In fact, the first dose is free. All I have to do is get outside. On the left is me out on one of our first birding expeditions in early 2022. Really got started again in earnest in late 2021 over the winter. So we got out in the cold on the Chesapeake Bay. That's the Chesapeake Bay behind me, frozen over. And all I needed was a pair of binoculars. A cheap pair of binoculars is sufficient for most things. And a smartphone helps because, like I said before, there are apps to help with identification and recording what you see. Now things have gotten a little more expensive for me. The photo on the right is me with my camera rig that I currently use with a 150 to 600 millimeter zoom lens on an R10 frameless camera body. You don't have to go that far. In fact, in bird photography, this is considered an entry-level camera. So it can get extremely expensive if you become slightly addicted to it like I am. So be prepared to save money if you want to get more bird pictures. Like I said, it's sort of a team sport played individually. So the Cornell Lab of Ornithology runs a website called eBird, which also has a database associated with it. They just had a big data migration this past week as they moved to a bigger and faster set of cloud resources to store their database. It's the virus total for birds. It tells you where they are, tells you who's seen what, and it also, you can keep track of other birders in your area, look at their lists, see what they're seeing, plan out your day. It's intelligence collection. I looked at eBird yesterday, saw that somebody had seen a large number of a bird I like at North Point State Park here in Maryland. We went over there this morning. I cut my visit short so I could get back in time to do this presentation. There are also active online communities in places like Facebook. It is fine. And because there are a lot of older people who are birders and they like Facebook. There are also mailing lists and things like that. And they're there to help new people learn, to help ID birds when people can't recognize them, and also for people to argue about the IDs of birds. I saw a very long thread, much similar to one you might find on, say, a Linux board about the identification of a bird, of whether it was a Cooper's hawk or a sharp-shinned hawk. So it's a lot easier to get started with birding these days because birding has become AI assisted. The Cornell Lab of Ornithology and Macaulay Library have put together an application called Merlin that actually does photo and song recognition of birds. They took their entire library of audio, broke it down into geographic areas, and trained a machine learning algorithm on bird song and on bird photos. So it's not 100% accurate. It's fairly accurate. I find that 90% of the time, 85% of the time, it's correct, or at least it gives you enough options about what you're looking at. With the photographs, with sound, it's more accurate. But there are some false positives, as we'll go into. Sometimes, because sound is hard, the sound recognition is based on essentially sound prints that are recorded by the device. Sometimes other sounds will be detected as bird song. So, for example, I was shooting photos of a woodpecker, and the shutter speed, the shutter clicks were detected as being a sandhill crane. So, not 100% foolproof. Excuse me. This is our opportunity to move over into talking about what AI is. The area of AI that is associated with what we're talking about, birding, tends to fall into the supervised learning category, where a large supervised learning is where you give an algorithm a pile of training data that has already been pre-sorted into identification, and you run it through with other data to teach it what is a specific bird and what is not a specific bird. The advantage of this type of learning is that it generates an algorithm that can run in a fairly compact space as a web API running on a server, or in some cases even on the device itself. And so I feel you're familiar with any sort of AI that you run as part of, say, malware detection or something like that. That's usually one of these smaller supervised learning algorithms where it's been trained on data to recognize something as being what you're looking for. There are other types of learning that are associated with other types of AI. Reinforcement learning is used in gaming a lot to train AIs to do tasks. Unsupervised learning is usually used when you have a set of data that can't be labeled, needs to be categorized in some way, and to find groupings of things to discover things that a human has not found in the data yet. There are other sorts of which get a little bit more complicated. So everybody's heard of generative AI at this point in one form or another. Either the large language model stuff, that is ChatGPT, for example, or as the most widely known example of it. Midjourney, Dolly, things like that that do image generation. They're great for all sorts of things, and it looks like lately the biggest use of image generation is to make really creepy Facebook images. There's this trend of shrimp Jesus going on Facebook. I have no idea where it came from, but that aside, the generative AI models, large language models, and image generation models are much larger, much more energy consumptive, require a lot more computing power. They can't generally be run in a framework that we would use for security or for birding. I can't run a ChatGPT agent on a phone to tell me what's going on with birds. Wouldn't be helpful anyway, because ChatGPT was not trained on birdsong, it was trained on human language. But so the one thing that AI is good at, going back to machine learning is very good at identification and classification. For example, this photo here, I've got two different kinds of gulls. I feed the photo into Merlin, and it recognizes the smaller gulls because they have a different color leg and different shading and the coloration of their head. Based on the library of images they've been trained on, they identify them as Bonaparte gulls, soon to be renamed. And the larger gull in background, they're identified as ring-billed gulls. The other thing that is used besides identifying marks is geographical location. So and there will be times when you get an identification of a bird that does not necessarily fit within your geography. They weight IDs based on location so that the IDs you get are more likely to be accurate. But if something is a standout, or as they call an erupted bird, they will put a little red mark saying we got this, but this really is strange. You should really get more detail on this. As I said before, so this is a screenshot of Merlin in action. You get true positives and false positives. For example, here you can see a particular call, Carolina Wren. Carolina Wren has 10 different calls or more. It is usually the bird here on the East Coast that when you hear a bird, you say, what is that bird singing so loudly? It is either a robin or it's a Carolina Wren. However, when I recorded this audio, there was some running water nearby, and something about the running water created a sound print that made it ID a killdeer. And then, of course, you have advanced threat groups like mockingbirds and blue jays. Blue jays have a tendency to mimic red-tailed hawks. Mockingbirds imitate everybody, and so you can get a missed ID because the bird is spoofing you. And so, yes, oh look, it's just like InfoSec. You have fooled me into participating in a hobby just like my job. Well, the one good thing about birding is that the birds are not trying to do bad things to people usually. So, but there are some lessons to be drawn from birding on AI that apply to machine language and not AI on InfoSec, and they are that machine learning and AI does not replace human perception. It can be a good assistant if given the right tasks, and it fails when the data set fails. So at this point, I'm going to take a break and take any questions you might have on the birds or on the AI with the birds before we move on to the InfoSec piece.
So the question that I'm seeing about the birds is how much do bird songs change from juvenile to adulthood, and how much does that vary by species?
It varies a bit by species. Juveniles don't tend, so most bird song is associated with adults who are in breeding season or are communicating with their mate. There are calls which are universal across the birds, but all bird song and bird calls are learned. So it isn't something they come built in with. They learn it from their parents and from other birds in their community. So just like human language, bird song is malleable, especially in species like, if you know, the European starling. European starling will sing based on what it learns from who raises it. So if a human being raises a starling will make noises off the television or mimic the person that raised them, that they imprinted it on, and they will not sound like a starling to other starlings.
Cool. That was the bird question.
Okay, so let's move on. So just as a preface, so in my day job, I work with a bunch of different groups at my company, and one of them is the AI group. Our AI team is doing a lot of research on how to apply machine learning and large language models, et cetera, to solving problems with information security. Some of those are at the detection level. Some of those are in the SOC. Some of those are in the Security Operations Center. So depending upon where the machine learning or AI is happening, the cost of using AI for a task determines how you address it. So, for example, detection algorithms, they can usually be built right into an endpoint protection tool or at some level of in between from the central console up to the back end where things are submitted for analysis. If you're talking about generative AI, that gets very expensive to run again, as I said. And so a lot of those things have to happen either at the SOC or in the cloud someplace, and they are, you have to ration them to some degree, just from the standpoint of how much they cost both the user and the company running them to operate. But AI is a co-pilot in that it sits alongside traditional types of detection, traditional SOC operations, and it's supposed to make life easier for human beings. So I started playing with AI in an InfoSec world back when I was at Ars Technica. I was doing some hunting of phishing kits, and I needed a way to look for phishing kits that were on domains that were spoofing other domains, spoofing domains of specific brands or government agencies and things like that, and try to catch them as they were being set up so I could see when the kits were dropped, so I could get a good look at the kits before they were deployed. And that led me to Wesley Raptor's Streaming Fish, which is a tool that is it's a guided learning, machine learning our algorithm that is designed specifically to spot phishing sites based on training data. You can adjust the training data to make it fit your specific domains that you're looking to see who's spoofing. It actually consumes the certificate transparency log of the certificate registrars and looks for domain names within them. So it's consuming a web service in that regard. So like other AI tools at this scale, it's something that runs in Jupyter Notebook. Most AI stuff happens. The OG old school machine learning stuff happens in training an algorithm, usually through a Jupyter Notebook using Python to do a lot of the coding to present the data to the model using various libraries. You can also get this stuff on AWS in SageMaker. Cheaper to do it on your own hardware when you're starting out. But if you're going to do something to deploy at a scale and you want to put it up there, there are a number of different cloud solutions to do this type of work. Almost all of them start off with you using Jupyter Notebook. So if you're not familiar with Jupyter Notebook, it's a great tool to do data analysis using Python and to consume data and turn it into other forms, regardless of whether you're going to use AI with it or not. So good tool to use in any sort of data-driven task. In this case, with Streaming Fish, it's set up with Jupyter Notebook, but there's also a command line interface that runs through a Python front end, and there's a database that sits in this environment, which is all running as it was deployed in a container, and you're able to in real time consume the certificate transparency stream and find sites that match. I used this once I moved over to Sophos to run down COVID-related domains where people were setting up scam sites based on and trying to draw people in with COVID-related information. Now, moving forward a little bit, we at Sophos did some work around doing Yara rule generation. So, one of the problems with running algorithms on your machine is that, you have to deploy the algorithm to your machine. And we wanted ways to use machine learning to be used on any device that could be to look for signs of, look for indicators of compromise, to look for files that were dropped, malware matching patterns, look through logs on firewalls that look like they match patterns. So to do that, we trained a machine learning algorithm on various data. You have to do it differently for each type of data you're working with because they vary so widely, and also you want this thing to be small, but to generate Yara rules. In this case, the original work we did it looking at finding PowerShell specific malware. So we ran through a bunch of different samples of PowerShell malware, obfuscated PowerShell that had things in it that were used as attack tools and things like that. And it generated a set of Yara rules that we were able to push out to investigators to use to look for this malware. And then we also did the same thing with SolarWinds, with the executable files that were associated with SolarWinds, put the samples into a library, ran it against them, trained the ML against it, and then we're able to generate Yara rules that we could deploy to people without having to send them the whole algorithm. So those are two ways that basic machine learning can be applied to things. Now they require a lot of data. They require a lot of data to train these algorithms. So I think we used 10,000 samples for the PowerShell malware Yara rule generator, for example. So you need to have a vast amount of data, and it has to be labeled. It has to be clearly labeled. That's how guided learning works. So lately, we've been looking at what we can do with large language models. So large language models can be, are like ChatGPT, have been trained on a vast corpus of human knowledge scraped from the internet. As a result, they are significantly large computationally, and they've learned a bunch of things. They can write okay code. It's not the greatest code in the world, but you can, if you want to have somebody write some JavaScript code for you, and you have very specific requirements, you can tell ChatGPT to write you JavaScript. It's mostly usable. Um, you can give it information and have it format it for you. You can generate structured information by giving it prompts. So when you deal with ChatGPT, when you enter things in ChatGPT, you're essentially providing prompts to the large language model to get it to pull information out. You can engineer your prompts in such a way that it delivers information in a form that is automatically formatted for what you need. One of the strengths of LLMs is they can extrapolate and infer a lot of knowledge from based on the corpus they were trained on. So there are different types of LLMs that are coming into use now, including Code Llama, for example, which is exclusively trained on doing code. But they can't do things that rely on data they weren't trained on. And this is both a blessing and a curse. So from a blessing standpoint, this is also a clue when somebody else is using a large language model to do something, that they use the large language model to do something. There's been a meme going around the internet recently around the scientific community searching for key phrases that come out of ChatGPT that indicate ChatGPT was used to write a scientific paper. So these gaps are tells, gaps in their knowledge are tells that help you identify AI content. On the other side, if you have a task that you don't fully understand or you don't really have the data to support, it's going to trip and fall on its face. We have tried some things with LLMs where we've had results that were worse than a coin flip in accuracy. Excuse me. So here are a couple samples of things we're doing to sort of SOC Copilot things for AI. First is, hello, Spring. The first is we trained with prompts, trained large language model to take natural language queries about what is running on my network, show me all the servers that have this process running under the admin user, for example, and use that to generate SQL commands that went against the database of all of our telemetry to find those things. And we've tested a few large language models with this type of work. They all do fairly well. We also looked at a couple of other tasks, such as doing spam detection. Again, because it's language-based, we give it we use this technique called few shot, which is giving it a couple samples in the prompt and asking it to identify whether this Linux block of text we're sending is spam based on the samples of spam and not spam we showed you. And it gives you an answer, spam or not spam. That, again, fairly accurate, high level of accuracy with only a little bit of data compared to what we get with having to train machine learning algorithm on finding spam. And then the last thing we've been trying to do is do lulbin detection, looking for command lines and identifying them as bad command lines or as an adversarial command line. And to do that, we started running the same sort of prompt, giving it the command line, giving a bunch of command lines that were legitimate and not legitimate, giving it the command line itself. Using its code understanding, was able to write code write a description of what the code did. We had to do that multiple times. And then we took the various descriptions it gave of the code and had that translated back into code by the AI again. And whichever one was the most accurate to what the original code was, we picked that description. This is something we're still tweaking. We're looking at deploying AI based lull bin detection soon. So this is something that is important to us. I think it's important to everybody. But again, LLMs do a pretty good job here. The problem is that they can't run in the customer environment. So, and you don't want to be sending the data, all of this raw data, to a third-party AI to look at the data and tell you whether it's spam or not, or whether it's an lull bin or not, because there's customer data in there that could be shared. So very sensitive in terms of, I can't use like a ChatGPT API to run these things. It has to be run in an internal hardware. The other problem we're running into is that the bad guys are using AI. And I mentioned before that, sometimes the gaps in AI are helpful in finding that. I've been doing a lot of research into something called pig butchering recently, which is a form of romance scam that if you haven't heard of it yet, you will soon, or learn more about it soon. John Oliver did a segment on Last Week Tonight on it already. I spent the last 2 years doing a lot of work on this stuff with my colleague Jagadish Chandrai, because the mobile side of this is pretty heinous. In any case, we found that first of all, the image to the left is one I received this week from a lure, from a scammer, trying to get me to believe they're a real person. This image shows a number of artifacts of it being an AI-generated image. So they used to steal people's social media images and things like that to present themselves as that person. Now they use AI to generate photos to use in their interactions with potential victims. And not everybody is savvy about the potential tells that are in AI-generated imagery to figure out that this isn't a real person. So you had to look at this image. This image came in on your phone. You would have to blow it up and navigate it around. This is a random picture from somebody. Why am I doing that? Her right ear is weird. There's some issues with the symmetry in the face that could or could not be AI artifacts, but there are other things in the image as well. We've also done some research about potential adversarial use of AI to do scam generation. So our AI team built a system using ChatGPT to automate the creation of fake store sites that would phish social media credentials from users, phish their credit card data, presenting product images that were generated by generative AI, even had audio from the owner of the store talking about how they had curated the collection. And this was could be done at scale for basically, you get about 400 fake websites for about $100. And that's using the ChatGPT API. We also found scammers using ChatGPT to respond to texts from potential victims. On the right, we have a screenshot of a chat that was going on between a pig butchering scam victim and the scammer. The scammer was reacting to an emotional reply from the victim, and they put it they to overcome their lack of fluency in the language of the victim. They put the response that had been sent to them into ChatGPT, generated this response, but of course, and then did some minor editing of it, which made it less grammatically correct. So that's where you get this block here at the top, where it says, as a language model, I don't have feelings or emotions like humans do, but I'm built to give helpful and positive answers. If somebody says that to you in a text, you're pretty sure that they are a large language model. So the problem is that we're seeing more and more of this sort of thing happening, and the people who are targeted by these are not, as I said, necessarily savvy about AI or about the things they're getting scammed about. So, with that said, I am going to open it up for questions. If anybody has any questions about other implementations of AI or how to apply AI to specific security tasks, if I can answer them, I will. Otherwise, I can take it offline and I can loop you in with some of our my teammates.
So the first question in the chat is, can Yara run a machine learning model, or are you using it for feature extraction and then shoving those features into some other external script that runs the model against the extracted features?
So what we're doing is we're extracting the features and then running a script that generates Yara rules themselves based on the features extracted by the regression that was done by the algorithm. So the Yara rules can then be run by any script. They don't need the AI to be run. They can be deployed wherever they need to be deployed. The thing is that you have to do a new regression for each set of data you're going to be doing a Yara script for. So this can be done back in the lab. You do this, you run all the samples through the machine learning tool, generates the Yara rule. And this is all open source. We have it up. It's up on GitHub. If you want to look for it, is a Yara rule generator is up on GitHub. So you can grab it and play with it and see what we've done so far. But yeah, you don't need the machine learning to run Yara rules.
Right on. There weren't any other questions in the chat, but I had a question for you. Do you have a favorite?
Great.
Do you have a favorite
bird?
Yeah.
Well, I stand for the Carolina wren.
Okay.
For all sorts of reasons. I'm also a big crow fan. So my personal relationship with crows goes way back, and predates any kind of relationship, any kind of like deep birding thing I was doing. At my house, the fish crows wake me up in the morning. Southeast United States fish crows. They are a nasally, honky cousin to the American crow. Big fan of them. The Carolina wren, though, small and loud. It is the best mascot for any underdog you would want to have. And like all wrens, it's the king of all birds. So the Carolina wren wins out right now.
Right on. I love that answer. Thank you so much, Sean.